Alright guys, so today in class you did an activity very similar to this. You took a tea bag and you lit it on fire and you observed what happened. And we asked you to try to figure out what was going on. So tonight we're going to talk a little bit about that and we're going to learn how it relates to balanced and unbalanced forces.
Alright guys, as you notice, the tea bag started to rise as the fire caused the bag to start to decrease in mass, and it created a convection current with the air. As the warm air started to rise up in the bag, it caused it to push up. What else do we see in relationship with the bag to its forces? What do we know?
Okay, so for your activity today, there are kind of two parts. And the first part, the paper was sitting on the table. It was not moving. And as we've already discussed, if it's not moving, then it's in equilibrium, and the forces must be balanced. So in this case, we have two upward forces. We have a lift force from that convection current and a normal force from the table pushing up on the paper. And then we have the weight of the paper going down. So, once again, to be in equilibrium, the forces up must equal the forces down. Therefore, the lift force plus the normal force must equal the weight, and the net force is 0, and therefore there's no acceleration. So this should all be review. But let's look at what happens for the second part.
As you notice the bag start to rise, the normal force has been overcome by the lift force. So the bag starts to increase. So when we draw our force diagram, we make the weight force smaller and the lift force starts to increase. So the bag will start to rise due to that convection current. The mass decreases, or the weight decreases. That mass doesn't disappear. It's converted into carbon dioxide and water. So as the lift force increases, the mass decreases. And with that, we're able to solve for the acceleration of our paper hot air balloon.
So let's say at the time of liftoff, the mass of our bag that's left is 0.0005 kilograms or half a gram, and that convection current is producing a lift force of 0.01 newtons. And we want to know what is going to be the acceleration of the bag. So first we need to write out our equation for our net force and how that relates to acceleration. So our net force is our force up minus our force down, and net force is always going to be equal to mass times acceleration. So now we rearrange to solve for A. So when we rearrange and solve, putting in our known values, we see that the acceleration is 10 meters per second squared, and because the lift force is greater than the weight, that is an upward acceleration, and we saw our bag accelerate upwards. Alright, so the big idea of today is then that if we have an unbalanced force, that we will accelerate in the direction of that unbalanced force, and that the net force is equal to mass times acceleration.